So good morning, everyone. I'd like to talk about this project called CODECHECK. It's an open science initiative to facilitate sharing of computer programs and results underlying scientific papers. This is joint work with my colleague Daniel Nist in Germany. And I'd like to just acknowledge the funders, Mozilla and the UK Software Sustainability Institute. And I have to declare some interests.
Sorry to interrupt you. Could you please share the slides?
I thought I was, sorry. Hang on a second. Thank you. Let's try again. Chrome. Did they appear and then disappear?
They didn't appear at all.
Let's try again. Okay, how's that? So I'll start again. Just like to point out this is joint work with Daniel Nist in Germany, and we thank Mozilla and the UK Software Sustainability Institute for funding. So if you want to follow along, these slides are at this bit.ly link. I'll put them on Twitter and in the chat later today. So there's lots of links to follow if you want to follow up on anything. Here's the basic premise that I think should be familiar to most of the audience today, which is that I think we're sharing the wrong kind of things right now in science. So most of the things that we share as scientists are on the right-hand side of the screen, the papers, the traditional way of communicating our results. But if I read somebody's paper, I can't get back to find their underlying data, code, results, and so forth. So what we should be doing, and there is this movement to try and share the things on the left-hand side, because given the materials like the data and the code and the results, we have some chance of sharing with other people generating our results. This is not a new idea. I think the classic quote here is that the paper is an advert for the scholarship. Buckheit and Donahoe were one of the first to say this. So in the case of computational work, what are the approaches today for code sharing? And my ideas all stem really from this Nature article in 2010 by Nick Barnes, which just said, publish your code, it's good enough. So whatever state your code is in, you should be publishing it because other people will benefit from it, right? It doesn't matter how neat it is, doesn't matter if it's documented. It's been written, it's something that you can easily share, you should be sharing it. And we can go into those reasons, maybe why people don't share later. But let's assume that you do want to share your code. How could you do it? Well, you could just develop an informal code buddy system where you share it with others and other groups, and they look over your code and give you comments on it. There's a sort of move towards research compendia in various scientific disciplines, and bioinformatics, I think, is doing quite well here, in that people are generating these compendia which explain how the results were generated. CodeOcean is a commercial entity that's trying to work with publishers. Nature just finished a big trial with CodeOcean about a year ago to show that we can be sharing code and sort of hosting it on the web for others to rerun. Interesting perspective for those kinds of projects where you've got patient data, for example, which is sensitive and you can't share it. In France, there's now this system called Cascade for sharing commercially sensitive or for getting somebody else to reproduce your results and write a certificate to say that was reproducible. Our system called CODECHECK is actually a little bit different. So systems like CodeOcean, I think, set the bar very high by saying we're going to make this code reproducible forever for everyone. And this sounds great, just going onto a website and being able to run somebody else's code. We've gone to the other end of the spectrum, which is simply to say, was the code reproducible once for somebody else, right? So not for everybody, but could we get it for somebody else independently at one point in time? So what we as code checkers do are just simply to check that the code run, and then we check that it generates the expected number and types of output files that the original authors say. The exact contents of those output files do not need to be checked, so that you don't need to show that you've got one-to-one equivalence with the original results. But by writing a certificate about what you find as a code checker, they are available for others to see. And it's important to stress here, we are not checking the validity of the code. So if the code has a bug in it, that bug will be a part of the reproducible package, right? So at least the bug should be reproducible. So here's a workflow of what we're thinking about. In top left, we've got the original researcher submitting some code and some data to either the journal, and the journal says, oh, we'd like to get this code checked. So they pass the code and the data to the code checker. And then this is the way we work right now is that this is an open communication flow between the author and the code checker, because it tends to be a dialogue to say, well, was it working? Yes or no? And, oh, I've got this problem. Can you fix it? And once the code checker confirms that the work is reproducible, the code checker writes a certificate, which then gets deposited. We're currently using Zenodo to store them. The certificate can go back to the journal, so they can publish this as part of their journal, as part of the record relating to a paper, and that gets deposited in the appropriate places. So code checkers are humans. They're like reviewers, but they're just checking the reproducibility of the code. Number two, if there's a problem, they just report that there's a problem. They don't necessarily fix it themselves. They go back to the author to ask the author to fix it. Credit is given to the code checkers. This certificate is an object that has a DOI. It can be cited as part of somebody's CV, and we hope that journals will also give appropriate recognition to the code checkers. And the result of these code checks are, as well as the certificate, are these workflows which we can say, this is how we reproduce this original person's work. So who does the work? Well, the author has to provide the code and data and provide some instructions on how to run it. The code checker is the reviewer, has to run the code, write the certificate, and the publisher helps oversee this process. Who benefits? Lots of communities benefit. The author gets a check from somebody else that their code actually works, and the code gets archived for future use. The code checker, as a reviewer, gets insights into the latest research and methods, gets credit from the community in a citable object. The publisher gets these certificates and these code and data bundles and signed up. Peer reviewers, if they see these certificates during peer review, they can relax. They know that the code has been checked by somebody else. They don't need to do it. And the reader can then read these certificates and realize that the code is immediately available, so that if they want, they can go and run it themselves. So this is our website, codecheck.org.uk. Right now we have 15 certificates that are being completed. So a typical certificate is listed down here, where you can see the contents. It just shows a list of what the code checker actually did, and to verify that the outputs match what was claimed in the original file, in the original paper. So I'm going to just highlight our most famous certificate here, which is the COVID Report 9, 2020-010. You'll probably all remember this face is Professor Neil Ferguson from Imperial, the famous COVID model that helped bring the UK into lockdown. There was a lot of debate at the time that the code underlying this wasn't available, and therefore it was ropey and it couldn't be trusted. Well, so we got together with the Imperial group after they had cleaned up their code with Microsoft and GitHub, and we checked that the results were independently reproducible, and we found that within sort of 1 or 2% differences, we were getting the same results that the COVID Report 9 had actually published back in March. Hilda Bastian summarized it when this was written up as, it ain't pretty, but it works. So this code is now out there. All of the code is archived along with the data sets that you would need to independently reproduce this. So I think this was a great success of the CODECHECK system. It's not the be all and end all of code checking, right? Here are some of the limitations. It takes time to do this, but code checkers need credit to do this. It's very easy to cheat the system because we're not checking every line of the code. We can't be guaranteeing that the code actually works as what the original paper says, but who cares? The key point is that if you're so interested, you can go and look at yourself, because one of the fundamental principles is for a code check, everything needs to be freely available under point 3. We're trying to come up with a deliberately low threshold for gaining a certificate, just so that these things take off. We don't have a solution yet for high performance compute, the COVID being a case in point. Ideally, we'd like to run this on public resources like my binder systems and so forth. That can't be done with the COVID simulations, which took an order of magnitude about a week on our Cambridge high performance compute resource. And we cannot yet support all thinkable existing workflows. We tend to work mostly with the Unix workflows where we can handle them well. So I'd just like to close by pointing out a few of our next steps. We hope that journals will embed these certificates into their workflows. We've had good conversations with eLife and GigaScience about this. We're working towards training a community of code checkers. And any funders out there, our Mozilla funding just finished last month. We're now looking for follow-on funding. Thank you very much for your time.